Assalamualaikum sir. My name is also Dan Pilibang and for my topic for video reporting is several methods to compute beam deflection, page 196. So methods to compute beam deflection, engineers use several methods to determine how much a beam bends under load. Each method has each method has its own advantage depending on the type of beam, loading, and required accuracy. So number one is double integration method. Uses calculus by integrating the bending moment equation twice to obtain slope and deflection. So example, a simpler supported beam with a single load at the center can be solved by writing the moment equation, integrating twice and applying boundary conditions to find maximum deflection at the midpoint. So number two is Macaulay's method, a modified double integration that use singularity function to handle multiply loads easily. Example ng Macaulay's method is a beam with 2 points loads at different points can be solved using a single equation with Macaulay brackets, making the solution simpler. Number three is moment area method. Uses the area under the bending moment diagram to calculate slope and deflection. Example. Example of number three. If the bending moment diagram forms a triangle, the area give the change in slope, and the location of the center gives the deflection at a point. Number four is method of superposition. A break a complex load into simpler cases whose deflection can be added. So, example of number four is a beam with a point load plus a uniformly distributed load can be analyzed by solving each load separately and adding the result. So, number five is conjugate beam method. Transform the real beam into a conjugate beam where shear represents slope and moment represent deflection. Example, used to find deflection and cantilever beams by analyzing the internal force of the conjugate beam. Number six is Castigliano's theorem. Based on strain's energy, deflection is found by differentiating the strain energy with respect to applied load. Example, useful for beams with several loads or complex geometry, such as frame with multiplied joints. So number seven is work energy, Betwell work method. Use better forces or virtual displacement to find deflection at a specific point. Example, applying a small virtual force at the midpoint of a beam gives the deflection at the exact location. So, assumptions in sampling binding theory. Beam is initially straight. Material is homogeneous and isotropic, uniform and same in all directions. Strain relationship is linear and elastic. Young's modulus is same in tension and compression. Sections are symmetric about the bending plane. Plane section remain plane after bending. So non-uniform bending is when the bending moment changes along the beam. Shear force occur at each cross section. This shear force creates shearing stress. Shearing stress causes warping, meaning cross section do not remain perfectly plane. Example, a cantilever beam loaded at the free end as high moment near the support and zero at the tip. This variation causes non-uniform bending and shear in those distortion. So that's all. Thank you.